Welcome back to part 2 of the Buffer Overflow series. In this video, we'll shift gears from what is a buffer overflow to how do we detect one. Let's dig deeper into what these bugs actually look like in real programs. In a previous demo, we saw how a simple buffer overflow can cause a program to crash or behave unpredictably. But modern systems don't always crash when memory is overwritten. That's why in this part, we'll learn how to detect buffer overflows, even when there's no obvious failure. We'll look at how to identify vulnerable code that could lead to a buffer overflow. We'll run a demo program and feed it both safe and overflowing input. Then, we'll inspect the output to spot subtle signs of corruption. And finally, use GDB to verify what happened in memory. The most obvious warning signs are unsafe functions like gets, strcpy, or scanf, without length limits. These functions allow unbounded input, making them ideal for triggering overflows. In real code, you should treat these functions as security risks unless carefully controlled. Let me show you the layout of our demo program. We define a small character buffer of 8 bytes. Right after that, we declare an integer variable called hacked initialized to 0. Then we read user input using gets. If we enter too much data, it can overflow the buffer and overwrite the value of hacked. Here's what you'll see in the upcoming demo. We'll compile the program using special flags to disable memory protections. Then we'll run it twice, once with a short input like hello, and once with a long string of A's. We'll see if the hacked variable changes, and then fire up GDB to inspect the stack and confirm memory was actually overwritten. For this demo, I will create a file using VI editor and use this C code. This C code has a custom gets function, as latest GCC compilers will not compile the code and will give errors. This code has 2 variables defined, buffer and hacked. We will overflow the buffer variable and it will overflow into hacked variable, as they will be next to each other in memory. We will also print this on terminal when this happens. Now let's compile this code. We still see warning, but code compiles successfully. Let's run the code normally by inputting 8 characters. As you can see, no buffer overflow happened. Now we'll input more than 8 characters. As you can see, input we added has overflown to hacked variable. We can confirm that in fact the value is overflown by converting value of hacked variable to hexadecimal. This hex value we receive is ASCII A, which we can again confirm as follows. So this 41s are overflown A's. This confirms that our input has overflown. Now we will use GDB to check registers. Set breakpoint at main and run the program like this. Use next to proceed further in code. We'll add incorrect input so that we can check registers. Use info registers to check registers. We will check SP or stack pointer register, which is used to store the memory address which stores data such as parameters, local variables. I am using Mac, so it is SP. For other x86 architecture, it will be RSP, which you can check with info registers command. Let's examine SP register with this command. As you can see, we are seeing unallocated 41s or A's in the memory. This again confirms the buffer overflow happened. Here's what happened during the demo. The buffer accepted more characters than it was designed to hold. Those extra characters overflowed into the space occupied by hacked. Although the program didn't crash, it showed that hacked was unexpectedly changed. And when we looked into memory with GDB, we saw that the variable had been filled with repeated 041, the hex value of A. So here's what we learned. Buffer overflows are dangerous, even without a crash. They can corrupt variables, logic, and return addresses without triggering a single error. To stay secure, always validate your input sizes and avoid dangerous functions like gets. Understanding memory layout is key to detecting and preventing these bugs. Thanks for watching. If this helped you understand how buffer overflows are detected in practice, drop a like and subscribe to support the series. Have questions or want to go deeper into GDB or debugging? Drop them in the comments. And as always, stay curious, stay ethical.